Here we go. We're starting. Shh. Listening. Eyes and ears towards me. Shh. Quiet down. Quiet down. Shh. All right. I want you to copy down this example here. You've got A. We're going to start off with A, which is a relatively easier example. So we're going to start with A. 3 times P plus 4 is equal to 18. So notice the language I was using just now. I said 3 times, even though we don't write it there. 3 next to a bracket means times. So remind yourself, anytime you don't see a symbol in between, it's always times. We're just lazy to put the time symbol. Okay, so 3 times P plus 4 is equal to 18. Now I'm going to show you there are two ways for you to solve this equation. 2 ways, okay? I'm going to show you, and which way depends on your strength. Okay, so you might find expanding the brackets easier, or you may be able to directly work with the example. Okay? Here we go. How do we answer this question? Now, there are 2 ways to do this. The first way, I'm going to use what you've learnt in chapter 5. Okay, so in chapter 5, you learn to expand the brackets. That's one way. In year 11 and 12, I normally tell my students not to do that because that makes it wider and bigger. But in the junior levels, you start off, this is okay. All right, so we'll do it. When you expand it in exercise, listening, in your previous exercise in chapter 5, you would learn to expand. So 3, remember it's 3 groups of P, but also 3 groups of what? Of 4. Very good, Krish. So we got 3 groups of 4. So I want you to write in the first step here when you expand it, it now becomes 3 times P, so 3 groups of P, and 3 groups of 4. So I'm expanding the brackets like you had done. Sitting forward, thank you. Equals to 18. So you see how I'm keeping the equal signs together? Okay, don't move it around. I see some of your working solutions, you're writing equal signs everywhere. It should just be where it starts, it stays the same. It's an equation, all right? So here we simplify it. What is 3 times P equivalent to? Let's go with AJ. What's 3 times P? What's another way of writing 3 times P? 3P, very good. So I'm going to write this as 3P because we're too lazy to write the time symbol. And then we're saying plus, what's 3 groups of 4? Yes, Cooper, who's laughing? 12, very good. So 3 groups of 4 gives you 12 is equal to 18. So you see I'm keeping everything the same. I've expanded the brackets. That's all I've done. Right? Your job now is to find P. That's what you want. You want to find what P equals to. Now remember I mentioned in our last lesson, you can balance the equation however you want to find P. I just want P by itself on one side. That means I need to remove this plus 12. And remember that's a times 3. That's a times 3 right there. So to remove, remember Sam Dobb? Instead of BODMAS, we're going backwards. So Sam Dodd, let's remove all additions and subtractions first. Now if that's a plus 12, what's the opposite of adding 12? Subtracting. So I'm going to say if I subtract 12 on the left, I need to make sure to subtract 12 on the right as well. You got to balance the equation. Okay, whatever you do to one side, it has to be done to the other side. So here we go. Let's work it out. What is 12 take away 12 on this left-hand side? 0, very good. So this is 0. You still have the 3P added to the 0. What's 18 minus 12 on the right-hand side? 6, very good. Now let's simplify this together. What is 3P plus 0? What's 3P plus 0? 3P, very good. Anything adds zeros itself. So, now you're almost there. We went from this equation, and we're now here. 3 times something equals 6. We know the answer is 2, but I want you to show me the working solutions to get there. This currently is 3P. I don't want 3P, I only want 1P. How do I get rid of that times 3?
You divide it by 3.
Divided by 3 because it's the opposite of times. Okay, so remember, this means times. So the opposite of timesing is divide. So that's why I'm going to divide 3 on both sides. See how I'm doing it in green? It's my working solution. I did subtract 12, subtract 12. Now I'm doing divide 3, divide 3. Now let's be careful here. What is 3 divided by 3 again? 1, not 0. Okay, a lot of students think it's 0. It's not. So 3 divided by 3 is 1. So I'm going to write it again. So this is now 1. And so you have 1p is equal to 6 divided by 3? 2. So now I know the answer to this equation has to be 2. So what does this mean? See, a lot of times students may not know what this actually means here. You're saying that if I have p as 2, both the sides should be the same. Let's see if this is true. 2 plus 4 is 6. 6 times 3 does give you 18. You see, you solved the problem. This was the problem, and you didn't have to trial and error to figure it out. You were able to solve it by undoing the problem or going backwards, and now you know that p has to equal to 2. This is method 1. Okay, so I want you to copy method 1. This is the one that most juniors will learn to start off with. So I'm going to write here, method 1. This is method 1. I want to show you method 2 now. This is what I teach to my seniors, because when the problems get larger, boys, actively listening or actively taking notes, one or the other. Okay? So, method 2. Method 2, this is how I teach my seniors, because when it gets really large, expanding it or expanding the brackets make it more terms, makes it harder to do. In the senior levels, you don't want to be doing too much mathematics. It's too hard. You want to simplify as much as you can. So in this step here, this is actually already simplified, so there's a better way to do it. Except, a lot of students may find this a bit harder to see. But once you practice it enough, you start to see it as an easier method. Okay, but you have to be sort of logical. When can you do this and when can't you do it? I'm going to show you this method, okay? So here we go. Same thing again. 3p plus 4 equals 18. Now, the goal is to find p. We know that between the 3 and the brackets is times. So what do I teach my seniors? You don't have to expand it to solve it, but you can also see it as, if I can get rid of that times 3. So you know that's times 3. 3 times the bracket. If I can get rid of the times 3, I don't have to expand it. So what's the opposite of timesing 3? Dividing 3. So this step, I can actually just say, divide 3 on the left, divide 3 on the right. Now this is why, remember how I said my seniors tend to make a mistake? I said that they just cross things off all the time. Remember, you can't cross things off when you have a plus symbol. I don't have a plus symbol here. It's 3 times this entire bracket. When it's times, it's okay to cross. When it's plus or minus, you can't. Okay, so if it was p plus 4 and 3, you can't cross them. But you can cross when it's 3 times something. All right, so here what I'm saying is you can simplify 3 divided by 3, which we know is 1. And so this now becomes 1 times p plus 4. But 1 times anything is itself. This is why we get p plus 4 on the left, and 18 divided by 3 is 6. Can you see how I already removed? I did the opposite of times 3. I divide 3 on both sides. 18 divided by 3 is 6. And 1 times this entire bracket is itself. So by doing this now, it's much easier to solve for p, because all I need to do is now get rid of plus 4. What's the opposite of plus 4?
Minus 4.
Minus 4. So here, I can say minus 4 on the left, minus 4 on the right. So I'm balancing the equation. And we know that 4 minus 4 is 0. So p plus 0 is equal to 6 minus 4? 2. Very good. Together, p plus 0 we know is p. That's why I know the answer is p equals 2. So you can see this is much easier, especially when you get to the senior levels. You can remove a really hard example by getting rid of it first. Okay? But that depends on the question and depends on the example. Alright, so right now I'm just teaching you the 2 possible methods. Likely they want you to go through this way. Likely they want you to use method 1. So the examples they give you, sometimes doing what I'm showing you over there might make it harder. It might actually be better to do it this way. So it depends on your question. Okay, so let's try another one. Here we go. Let's do another example. I'm going to do, let's do B. So B has a negative here. Let's do B. All right, let's do B together. B, you have negative 12 bracket 3Q plus 5 is equal to negative 132. Now you can use my method, okay? You can use my method in dividing, or you can use method 1. Now likely, like I said, most of these questions are going to be designed for you to use method 1 and not my method 2. So let's have a look here. This is example 2, B. Okay? Same thing again. If we're using method 1, negative 12, remember in front of the brackets means times. This is a negative 12 together. Okay? It's currently timesing. Don't do plus 12. A lot of students think, oh yeah, I can do add 12, cancel them out. That's not true. The reason why that doesn't work, listening, the reason why it doesn't work is because it's not adding, it's a times symbol. It's times negative 12. So you can't say, let's add 12 and cancel them out. It has to be the opposite of times. So, if you wanted to cancel out this times negative 12, the opposite of timesing a negative 12 is divide. So here, I can divide by negative 12, but if I divide by negative 12 on the left, I divide by negative 12 on the right. Okay, now, listening, actively listening, or actively note-taking, but not actively talking. Thank you. So here, we're going to work it out. What is negative 12 divided by negative 12? 1. Very good. Anything divided itself is 1. So I know this cancels out to be now 1. And 1 times anything is the same as itself. So hence why you have 3q. I'm just going to try it again. Here we go. 3q plus 5 is equal to... Now over here, what's 132 divided by 12? Positive 11. Very good. 132 divided by 12 is 11, but double negatives, so don't forget double negatives is positive. So that gives you positive 11. So now this problem is much easier to do now. You got 3q plus 5 equals 11. That's exercise 7b. Let's try it again. Same thing. Sam job. What do I need to get rid of first? Plus. Very good. This is a plus 5. Remember, remove all the adds and subtracts first. So plus 5, the opposite of adding 5 is? Minus. Very good. Minus 5 on both sides. That's what I'm doing there. Now, 5 minus 5 we know is 0. That cancels out. And you're left with 3q on the left. And on the right, 11 minus 5? 6. Very good. We're almost there now. Our goal is to find q. But right now, this is q times the 3. So to remove the 3, I have to? Divide by 3. Very good. It's the opposite of timesing. So divide by 3 on both sides. And we can see here, 3 divided by 3 again. What is it? 1. Very good. Not 0. Not 0. Okay, 3 divided by 3 is 1. So I've got 1q is equal to 6 divided by 3? 2. That's using method 2. See what I'm doing there? Now, method 2 works for these two examples nicely, but it won't work well unless your fractions are really good for example C. So I'm going to do example C, and I'm going to show you why it's a problem, okay? So here we go. Let's have a look at why my method 2, you can't always use method 2. So here we go. So in the junior levels, they normally give you problems so that you have to do the expanding method rather than my method that I just showed you. Let's have a look at this example. So why can't we use method 2 for this example here? You see here, you've got the brackets again. Now, if we followed what we did over here, we said that was negative 12, and you divide by negative 12, right? Well, here has a 4. Naturally, you would say, let's divide this by 4, because that's the opposite of times 4. But what's the problem already?
57 doesn't go into 4.
Very good. 57 doesn't go into 4, but there's also one more thing that a lot of students tend to miss out on. What am I missing right now? I still haven't done something, and this is already incorrect in this step. And this is what I have to fix my seniors to be careful of. What am I missing? I do have to do the plus first, but let's say if I decide to... Remember I said there's never a wrong method in algebra as long as you're doing it to both sides. Now, I said divide the right by 4. I'm dividing the left by 4, but there's a mistake already.
Isn't it, you're not dividing the 3x?
Very good. Why is it that I have to divide the 3x by 4 as well? Can anyone explain to me? Because this is the common mistake that goes from year 7 all the way up until year 12. I'm still fixing students who are not dividing that 3x by 4. Because they're like, yeah, balance the equation. I've done it on the left. I've done it on the right. Why do I have to do it to 3x as well?
Is it because it's a separate, what are they called, term?
Terms, very good. That literally is it. Remember I was teaching you about terms? I was talking about if they are together, that's one term. All the examples that you had up here before were not separated by a plus or minus. See, this one is not separated. It's negative 12 times this bracket. So they're together. Even though they have a plus, that's now being multiplied to the negative 12. So the multiplication pulls them together, so they become one term. But here, you're right. Because this is separated by a plus, you have to divide them all by 4. Every single term you get has to be divided by 4. If you're going to do it on the left and on the right, you have to divide them by the number of terms they are. Yeah.
Say it fitted easily into a 3.
Yep.
In like a normal equation, say just 4x as well there.
Yep, let's make up one right now. So let's say
That
8x.
be then uneven because you've divided the left twice by 4 and the right once. But does it, if there's 3, you can't do it unless there's a second one on a second term on the right hand side. Or there can be like 10 different terms on the left hand side, but still one on the right hand.
Correct. Correct. So just to clarify Michael's question, if you're unsure what he was asking, if this was the example, right? This on the left-hand side, you've got 2 terms. You've got 1, 2, and then on the right, you've got 1. When you do decide to divide 4 on one side, you have to divide them all by 4. That's how it works. Every term has to be then quartered. Otherwise, it's not balanced. So, in his question, even if you had 10 terms, so I'll give you 10 terms right now. Let's do 3ab bracket x. Oh, my pen died. Let me do it on, here's my texter. Let's say I did 3ab x minus 1 bracket 5b minus c equals to 10, right? This technically